the hilarious thing for me. So they gave you such a hard time about it last class, and then told you you make an excellent quiz question. Ay, ay, ay. All right, so 2989. Let me make sure this is recording.
I was on the right step. I just hadn't put it in the
So 2989 divided by 16. How many times does 16 go into 2989?
13, which is the match to B. That's how my brain works. Well, the remainder is 13.
2989 divided by 16 gets us 186. 186 times 16 gets us 2976, which is remainder 13. So that's remainder 13. Keep pushing the wrong button. I want this one. So that's 186. 186 divided by 16. 186 divided by 16 is 11.625. So we're going to say 11. 11 times 16 is 176. So that's remainder 10. How many times does 16 go into 11? 0 times. So we know we're done. 0 times 16 is 0 with remainder 11. We read our answer from bottom up. BAD. 11 is a B. 10 is an A. 13 is a D. Last time we mentioned that base 16 legal characters are 0 through 9, A through F. Right? So you almost had it, Doomer.
I was doing mine already.
At least Doomer get most of the points.
I just ran out of time.
Yeah.
It was just taking me a while.
I think that was like a minute, maybe.
Yeah. It was just taking me a while to do it.
Oh, I gave you more. It was 2 minutes.
I probably needed like a full 5 for that one just because my brain's slow in terms of doing
You have a calculator.
It's on a Moto E.
You don't need a modulus function.
What do I do?
I'm rocking a Moto E right now. It took me forever to find the calculator.
What's this?
That's the only way I got it fast enough was I had a calculator.
You had the modulus?
No.
You don't need to have modulus.
Why not?
I didn't use modulus.
It takes longer.
Yeah, it takes like 4 hours longer because we gotta do all the times 16 minus the thing, and there's the remainder.
It takes a minute longer.
I think had I used the calculator on my computer, I would have been better off. Just for terms
If I
of
was
typing
using
stuff
Google
in.
and
So
type
like,
that
I never
number
used a
in,
calculator on here. It took me a while to find it.
Is it actually good for you?
I did tell you to show me the work. So if I could see that you knew what you're doing, I might have mercy.
Yeah, because I show every step of my work.
All right. So, any questions about that? What if I wanted to take BAD and convert it back to base 10? Let's just say at some point somebody gives you a quiz like this.
The next class.
It says convert that hexadecimal number to base 10.
Interesting.
What if I said convert that binary number to base 10? Could you do that?
I would use the inner, which is like what I think everybody.
I would
Very important we understand this stuff as computer scientists. This isn't a memorization type science. This is a problem-solving science. So you can convert this, right?
Yeah.
This is the ones place, 2s, 4s, 8s, 16s, 32s, 64s, 128s. So this is 128 plus 32 plus 16 plus 4 plus 1. So whatever that adds up to, that's the conversion. This is the ones place, the 16s place, the, 256 place?
Yeah.
So That's a 11 times 256 plus a 10 times 16 plus a 13 times 1. So 11 times 256
I think it would have been faster.
plus 10 times 16 plus 13 times 1. So 11 times 256 is 2816. That's 2816 plus 160 plus 13. $29.89. Exact same math we did here. To convert binary to decimal, we use the exact same math to convert hexadecimal to decimal. We use the exact same math. What if I gave you a quiz and I said, show me your work and convert 2989 from base 10 to base 10?
Oh, I could do that.
Always gonna do it next class. Just write 29.89.
No, which is show me your work. This is the ones place,
Yeah.
tens place, hundreds place, thousands place. So we have 2 times 1,000
Before
plus
you finish, you should just have a second
9 times 100 plus 8 times 10 plus 1. Oh, what did I do? I started off with the first number. 9 times 1, which is equal to 2989. It's the exact same conversion no matter what base we're doing. So we don't worry about, oh, well, I know how to convert from binary to decimal, but I don't know how to do hex to decimal. Same, identical, which was the point of the base to decimal and decimal to base functions you wrote in 250. That whether you remembered or not, every one of you wrote if you took 250. Well, I mean, that's not my problem. It's a prerequisite for the course at some point. It's a prerequisite for the prerequisite for the prerequisite for the prerequisite or something.
Even if you did it right, we went over it in class.
Yeah, it's true. So, yeah, it's just terrible. 2.5 people
I showed my work.
with a warning.
I was on the right track. Like
Yeah, so I would say, relatively speaking, expect demoralizing quizzes like this relatively often until things improve. You should be able to do this stuff. I will look at the work, though. So if you can show me you knew what you were doing and it was just a time thing with the math, I won't completely destroy you.
math and me don't know. I can't do math anymore. Everything I just do reverse.
All right. So, homework assignment. Let's get rid of this crap first. Was, what, the stack?
Yep.
Dealy flippy?
Yep.
All right, so we were supposed to write a constructor for a stack, right? And what's the stack constructor supposed to return? Empty list? Okay. Huh?
Empty stack.
Empty stack. Oh, was it the word empty stack?
Yeah.
Oh, so define stack to be a lambda. Oh, was the constructor called empty stack? Okay, is that what you're telling me? All right. So empty stack like that or underscore? Like that? And this guy's going to take in no parameters and he's going to boil down to the empty list?
Yep.
Yeah, that's good. All right, so that's our empty stack function. So that creates for us an empty stack. What about, what we have to do, push, pop, peek? Or top, but push, pop, top. All right, so top is a lambda that takes a stack as a parameter, right? And boils down to the car of the stack as just an element, right?
What if it's an empty stack?
No, you don't have to check for errors. It's not a big deal. think I told you last time the purpose of this assignment was to focus on building constructors and accessors.
Stack an actual keyword in Scheme or?
I don't know. If it is, change the name of this to ST or something.
Okay. I was just wondering because I use this.
Yeah, we're going to find out pretty quick. All right, so top, this guy actually returns the value that's at the front of the stack. He lets us peek at the top of the stack. Define pop. This guy should probably return the stack, because we're dealing constructors, right? This should probably deal with the stack that is the result of popping the first element off the current stack. Correct? Okay, so that's going to be footer stack. And define push to be a lambda. And this guy should return what? Actually, it's not just taking in a stack, it's also taking in a value. Or val stack, you can decide whichever one. And how do I build a stack? We're going to cons val onto stack. Like that. So we should be able to construct a stack using empty stack. Let me kick it down a line. Okay, so this guy will boil down to a stack. I can then push onto that stack the value 1. I can then push onto that stack the value 2. Let's just see what that looks like. That's the stack 2, 1. I should be able to then, let's just define S to be this guy. And then I should be able to call pop on S. And that gives me the list 1. I should be able to call top on S, which just gives me the 1. So, I didn't change it. I had the push. So that gives me the top of the stack, which was the 2. Make sense? Kind of understand the purpose of why we wrote these? This wasn't about writing scheme. This was about working with constructors, as we mentioned last time. All right? So most of us probably should have found out you're better at conceptualizing the idea of building things and using them than you are at writing scheme right now. Most of that has to do with we're weak in recursion, right? All right, and the other half is we're trying to make this stuff harder than it has to be. But this stuff is more familiar to us because we're used to working with object-oriented languages. We understand the concept of constructing an object, then using that object and building onto it and things like that. So even though this was still kind of a cryptic format, it probably came easier to most of us, right? Sure felt, in fact, I think we had a student complaining about the assignment being too easy, Trey?
This was the first time that I had a clue what was going on right at the beginning of the assignment and I was worried.
Now, wouldn't you agree that I typically give assignments that challenge you and then help you understand the stuff better, and somehow in the end you guys end up with better grades than you probably deserve? Does that all sound relatively consistent with how the classes typically go?
I usually fail anyway.
You usually should. I don't know if you ever have. I'm just saying, even though I do enjoy punishing you, there is a means to an end and a method to my madness. So, when I tried to embarrass you with stuff like this, try to learn from it, I only count some of the quizzes. You just don't know which of the quizzes I count, is the problem. Right?
Why'd you cancel the 3-star problems?
Well, because I don't believe in busy work. And after I looked at the problems, majority of that the second one had a little bit of constructive stuff, but most of it would have just been busy work just to be work. And you guys have better things to do with your time than that.
The first one was alright.
Well, the first one just wasn't that hard. It wasn't that constructive for what we were trying to do. All right, so we're going to talk about environments today. And I'm going to use the book a little bit just to kind of represent this idea of an environment, but we're going to kind of go off on our own little tangent with it. So as you're solving problems related to environments in the book, questions that I give you, I guess I don't necessarily care which version you use, but I would encourage you to use the implementation we're using in class. Okay? One thing you've probably already noticed is sometimes the book talks in circles a little bit. So I'm going to try to, because right now we're actually starting to talk about language constructs. And what we're going to talk about today is the idea of a variable environment. We've already stumbled upon some problems where we've recognized the need for variable environments, right? This kind of comes full circle from your very first programming class when we talk about, the three things that programming languages do for us. While human beings solve problems with memory, asking questions, and repetition. Number one on there was memory. Memory, every single programming language is going to give us facilities for dealing with memory through variables usually, dealing with conditionals through questions through conditionals, and dealing with repetition through loops. All of them, 100% of languages are going to do that for us, right? All right, so given that, it would make sense that programming languages need to have a facility for a variable environment because we need to have some place to store our variables. So what we want to start thinking about is, well, we're used to using all these languages like Java and, excuse me, some of you are taking the Swift course and that kind of stuff. Every single one of them have variables. Every single one of them, we've had to wrestle with this concept of variable scope. And what's variable scope again? What is it? Somebody who usually doesn't answer. When I say variable scope, what am I talking about? So let's get a couple people's...
instance in which you can access the variable, like where that lives.
Yeah, where we can access a variable, right? So where we access a variable is the scope of a variable, okay? So that implies that different variables may have different scopes, right?
It's like Oreos.
So under the hood, we need to be able to somehow have a data structure that governs the idea of a variable environment that explicitly manages scopes. Sound about right? And that has to exist somehow. We've never forced ourselves to think about that. We just kind of take for granted that, oh, well, Java creates scopes. If I create the variable here, I have access to it everywhere. If I create the variable here, I only have access to it in here, right? And variables always resolve to their most local definition. Therefore, it has to resolve. What does it mean for a variable to resolve? It means I have to go and look up that variable name and pull down its value. That's resolving a variable, right? And a variable always resolves to its most local definition. So if we're dealing with something in Java, let me just open up a text editor here. Excuse me. I'm at like the worst part of a cold right now. The part where you're actually better but can't stop coughing. Well, I don't have a fever anymore. I'm really better. Just coughing. So I'm trying to drink lots of hot liquids just to melt away the awesomeness. All right. I probably shouldn't have put that much creamer though in my coffee.
That'll probably just make it worse.
All right. So for example, if we let's just write a stupid little Java program real quick. So if I have public class blah. Public static void main string array args. And I say int a is equal to 5 here, and I say system.out.println a, and let's just create an int b, just so it'll technically compile if you guys type it in. Int b is equal to 7. And then I say print out b as well. This line's going to print out a 5. This line's going to print out a 7, right? All variables boil down to their most local definition. A resolves to its most local definition. And where are the places that I can look for A? Well, I can look for A as a local variable defined here. Then I can look for A as a local variable defined here. What's this part right here like for what we've been dealing with in this class? The identifier, yeah. Production 2 of our lambda calculus expression, the single identifier in our current grammar for that, right? That's what that dude is. Okay, just kind of connecting some of those dots. So I have really 2.5 variable environments here, but just for our understanding of the layers, let's say we have 3 variable environments. We have the most local environment right here. That's the environment that has a single variable in it called A. Then we have a little bit less local environment right here. The reality is this guy and this guy live in the same environment. That's the reality of it, but let's just roll with this for right now. So the most local environment, a little bit less local, and then even less local. So we have 3 variable environments right here. Okay? And if we were to represent these guys, we might think about this as a list of environments. Okay? Or a stack of environments possibly. All right, so I have a B is equal to 7 right here. That's my most global environment. But more local than that, I have an environment where I have args is equal to something. Let's just say somebody passed something into it. Okay, probably nothing if you took in 0 parameters. And then even more local than that, I have A is equal to 5. So when I go to print out this variable A, I need to resolve that value. So I'm going to I'm going to pop my most local variable environment off the stack. And right now I'm just assuming environments are single name value pairs since I didn't do multiples here, but this gives us the big picture. So I'm going to pop this off the stack and say, oh, I'm looking for a variable named A. Does that variable environment have a variable named A? It does. Its value is 5. Resolution complete. Right? I've finished resolving that variable, and I can print out 5. Easy peasy. Didn't have to do very much work. Now, I'm going to go down and try to resolve the B. It's going to go back to my same variable environment, my environment of environments. I'm going to pop the first environment off and say, is B found in there? No. Okay, I got to look at the next local environment. I'm going to pop that guy off. Is B found in there? No. I'm going to go to the next local environment. Pop that off. Is B found in there? Yes. So I'll finally be able to resolve B. Okay, but understand the number of steps we just had to take in order to resolve B. We had to look in 3 different places. Like hide and seek before we found it. What if I had said, just to make this work technically, blah.b? Because B is actually a class variable, so it's owned by the class. Therefore, we would access it using the name of the class in which it was defined. So if I say blah.b here, what I'm doing is I'm saying, go ahead and just jump to the end. Don't check these local environments. I've told you where to find it. I've given you the full path. Does that make sense? That gives us a shortcut. We don't check here. We don't check here. We just go right here. All right, so do we understand the concept of this variable environment thing? It's the place where our variable value pairs live. Okay, we have to have them live somewhere. We take it for granted as programmers because we're always using variables, not having to define where variables live. We define them, they're there, everything works, we're cool, kind of like when we're driving a car. Okay? As long as the engine turns on and the gas pedal does what it's supposed to do, I don't really care how it works under the hood. But unfortunately for you guys, we're computer scientists, and we actually have to care what's happening under the hood. Or at least for you guys, I guess, in here, pretend like you care what's happening under the hood, because you have to do it anyways. But I encourage you to care, because I actually think the stuff you'll learn in here as well as the compilers class next semester, is far more informative type stuff that you'll be able to apply to so many other problems that you're not even considering right now. You know, and this is compatible with Dr. Locklear when he says that the grand ideas of computer science. It seems like such a corny phrase, but the reality is all of these things are connected to each other. Every single one of them, you know, from the class that you perceive to be the easiest class to the class you perceive to be the hardest class, they're all talking about the same crap, just from different angles. Okay, and some of the angles we're a little bit more comfortable with than other ones, because it doesn't seem like it's as cryptic or things like that. All right, so when we're building a programming language, we need to consider the programming or the variable environment data structure. Now, when I say data structure, what is that? What pops into your head right off the bat when I just say that phrase, data structure? Okay, well, actually, you know, Beyonce, I really, really like that definition. By the way, for those of you who didn't know, his nickname is Beyonce. That's why it's on Slack. So I gave it to him, and for some reason it fits.
You just don't have a reason for it.
Yeah, and that's the thing. I don't have a legitimate reason.
The reason behind it was it didn't sound wrong.
That's it. That's the strange thing. Like when you look at him, you say his name is Beyonce. You look and says that doesn't sound wrong. And I can't even explain it, but it works. But in any case, I was about to compliment you. I like that answer. All right. So often, so you know what he said was it's a structure for holding data. So it sounds like he just kind of rearranged the words I asked, right? Okay. So often, what happens is when you guys have had 300, and you think about a data structures course, the thing that first pops in your mind are things like linked lists or stacks or queues. Those are our data structures. They're the guys that have been labeled as data structures, and they're super meaningful. And they're in the old computer testament as Christian, yeah, written down somewhere, and they invented them a long time ago. Now we just use those old fellas. And the new kids, we don't work with data structures. Data structures are just structures for holding data. Now, how many of you, and I've probably talked about this in some other classes that some of you may have been in, so this isn't one of those guarantees hex things. How many of you have heard of something called a design pattern? At least the phrase. All right?
Heard somewhere.
All right. What is a design pattern? If for those of you, a couple of you who've heard of it, understanding that there's a whole lot of technology-y buzzwords that float around now out there that people use all the time that they don't know what it means. So if you don't know what it means, that's okay. Take a guess. What do you think a design pattern is? Pattern for design. Now, technically that kind of works out right, but that's not a good compliment. That's not a good definition. And actually, hold on. All of you have had 325, or not 325, software engineering, right? Didn't you talk about design patterns in software engineering? So everybody here should have at least nodded that they've heard of it, right? Okay, go ahead.
It's like the overarching framework of how you create your software or application. It doesn't have anything to do with the application itself. It's like how the application interacts with itself, almost like we did in 390, the model view controller. It's the idea of separating the visual component from the data component.
Okay.
That makes it a better application.
Okay, got it. So let's create a more simple. You're right. He's right, and he used a good example. The MVC, model view controller, is a very popular design pattern. All right. The generic definition of a design pattern is best practice approach to solve a common problem. I'm going to put common problem inside of quotes. These common problems come in all sorts of different shapes and sizes. If I'm working for Lockheed Martin building fighter jets, common problems for me might be missile tracking type things. Okay, well, I'm working for Lego. Common problems might fall into very different categories. Okay, so
How to make it as painful as possible.
Yeah. Now, so the interesting thing with design patterns is right off the bat, when you hear that phrase, you feel like it maybe means something very formal or possibly difficult or something like that. You know, like it's mysterious. In the big scheme of things, design pattern scheme of things. See, I made fun of you there, Christian worldview. So,
Is that the way that works?
so the idea here is that design patterns are kind of a cop-out for academics, in my opinion. So at a lot of universities, academics have research requirements. You know, so we're supposed to publish papers and all this crap. Oh, design patterns, these are our go-to moves for free papers. It's like, well, I'm going to come up with a problem that I'm going to call a common problem. I'm just going to suggest a solution that probably will work, but I'm not even going to test it. Okay, I think it sounds like a good idea. I'm going to write about it, make it sound all foo-foo-y and stuff like that, all researchy, give it a funny name, that kind of stuff. We're going to publish it. Worst that happens, somebody says, you know what, I have a better idea for solving your common problem. He says, you're right. Still got the publication. And that's why there's a million design patterns out there. All right. All a design pattern is a best practice approach to solve a common problem. Somebody has suggested this might make sense for how to solve a problem. And then the popular design patterns are the design patterns that other people look at it and say, you know what? I agree with you. That is a good approach. So, for example, you mentioned MVC, the model view controller. Okay? What's the idea of the model view controller? What's the design pattern for? It says, you know what? All of our applications tend to have interfaces, graphical interfaces, and then they also have code that makes them work. You know what would be a great idea? Instead of squishing all those together so we just have this giant collection of garbage, let's split them apart. Keep our interface here, keep our code here, and we'll just come up with weak ways to kind of connect them, loosely connect them. That's MVC. That's it. Kind of seems like common sense, doesn't it? Okay, so most of these, kind of the punchline here is a lot of these things sound like they're way more complex than they are. And another popular design pattern is the singleton design pattern. Oh, love that one. Singleton. I mean, it sounds maybe something spacey. Isn't there something like the singularity or something like that? When I hear singleton, singularity kind of seems sci-fi for some reason. Okay, what's the singleton design pattern? It says, you know what? If you have, and this is really something relatively recent, as we have multi-page applications, pages, the mobile apps, let's say, that have multiple screens. You know what? You have a bunch of screens in your application, and they all need to share some data. You know what would be a good idea? If you put all that data in one place, so they all can access it. That's the singleton design pattern. That's it. As opposed to passing the buck every single time a screen, if you want to have a username, the current logged in username on every screen, the first screen lets the second screen know, here's who's logged in. Second screen lets the third screen know, here's who's logged in. So on and so forth. All right? The singleton pattern says, you know what? Get in if you need it. Make sense? All right. That's what design patterns are. Approaches. Just like we were talking about here with our data structures. We have some common data structures. Linked lists, stacks, queues. So we have those are our linear data structures. Then we have our non-linear data structures, our trees and things like that. So these are all things that have been long-term, common data structures that have existed for years and years and years. Old stalwarts in the in the data structure world. But a data structure at its core is just an object. So let's at least, so we'll fix Beyonce's definition a little bit and say it's not a structure. We won't use that twice. We won't use a structure to define a structure. We're going to say it's an object that holds the pieces of information required for representing certain kinds of data, representing and working with certain kinds of data. All right. So a linked list is a generic data structure for working with collections of things, collections of objects, right? Stacks are also a generic data structure for working with collections of things in a very specific way. Things that go in on the top of the stack and come off the top of the stack. Okay, a last in, first out type of order. A queue is a specialty data structure for working with collections of things where people get at the end of the line and come out of the front of the line. That's it. Okay? We're going to have a data structure here for working with variable environments. Specifically, a data structure that's built in order for us to represent our variable environments like we looked at right here. Something along these lines. Now, if we are implementing this, we can certainly say, well, at some point we could, excuse me, I hate coughs. At some point we can come up with best practices for representing our variable environments. And we'll look at a couple of iterations here. But as I've always said, you always want to come up with an accurate solution first. Let's get it working. Who cares how inefficient it might be or something like that? Let's get it working. So we want to come up with some collection of constructors and accessors, let's say, that allows us to build a variable environment, add on to that variable environment, and ultimately be able to look crap up in that variable environment. Sound good? And that ultimately will be a data structure. Okay, or I guess synonymically, is that how do you say synonym? Synonymous. It's not, well, yeah, but that's, I don't want to say it's synonymous with, I want to say synonymically, yeah, I think it's synonymically. Is that a word?
Yeah.
It sounds like it should be, and if it's not, that's awesome. Synonymically. That's a tough one to say, too.
It definitely does not sound like a word.
As the word of the day.
Definitely not a word.
Levi made it up. I trust him implicitly.
Synonymical.
Synonymical?
Adjective.
Synonymically.
Is a word.
Is that what you said? Synonymically? Synonymically.
Is it?
Yeah, we might. It was a pronunciation thing, I think. Yeah. Okay. So,
I'm synonymous with.
yeah, I got the synonymous one, but that's not how I wanted to say it. I wanted to say it like akin to like programmatically, that version of synonymically, synonymously. Yeah, but that's
a word according to
yeah, I know that one is, but I have to use that in a different tense, right?
You can't make it an adverb. It's an adjective.
Yeah.
You can't make it an adverb
So,
by adding an ly onto it.
all right. So, in any case, you know what I'm saying. So, well, let's go ahead and just look at the suggested data structure representation for our variable environments. All right. So, again, we have a constructor for our empty environment. So we're going to say an empty environment is just the empty list. Fair enough? Empty environment, empty list. So let's go ahead and define that real quick. All right, everybody good with this stack crap? We understand how it was our kind of our gateway drug into thinking about, it's also Christian worldview, into talking about the, into talking about this idea of data structures and constructors and all that garbage. All right, so we're going to say define empty env to be a lambda that takes no parameters and returns the empty list. All right. Now the one thing we want to kind of get over here is at initial thought, this looks like a wasted time, right? Hopefully at least some of you have asked yourself that question. Like, okay, well, empty stack, empty env, whatever we did last time, the base bidget thing. We start off with nothing. Yeah, the bigots. We talked about the bigots, and all bigots have cars. And if you missed last class, highly entertaining lecture that probably belongs on something. Like an example of out of context, one of those out of context things. Like, here's a snippet of from some classroom experience at Concordia University. Like, what the heck? I'm not suggesting you do it, but it would be kind of funny.
So the next, just reference that video for the next admissions video.
It would be kind of funny if somebody went through and edited that and just really pulled out individual pieces that just sound horrible when put in a certain way. And like just send it to Dr. Locklear. You're like, we just thought you should know.
I think some of last year's classes would be worse.
Be a tough one there.
I've already said too much. All right. So punchline is we might think that this is a waste of time right here. But really it becomes like this chicken or the egg thing. We have to have a starting point that we can build everything else up on. We don't want to build on top of quicksand. So we need this base constructor that gives us kind of our almost like pouring a concrete slab to build a shed on or something like that. We need that as our starting point. So that's what these almost like empty constructors are for. Kind of makes sense? And we're going to take this even a step further. We've talked about this with our other languages when we talked about object-oriented constructs and how object-oriented languages are built. We're going to talk about kind of the first object. At some point, we have to have a constructor that makes the empty object, the nothingness object, the object that doesn't have anything associated with it, of which we want to extend to make it into fractions, into dice, and all sorts of other things we might want to build objects of. Okay? So there's our empty environment. All right, then we have this idea of extending an environment. All right, so this is an action we will take on something that is an environment where we say, here's a variable name, here's its corresponding value, and here's the environment we're extending. And ultimately, we'll produce a new environment. Make sense? So we take an existing environment, we extend it with, in this example, one variable name, one variable value, so we don't get to have multiple variables in our data structure yet. And then the old environment that used to be there. Okay? So if we're going to write the function for extend env, what's this guy going to take in as parameters? Extend env takes in a, I'll put it up here. Don't all speak at once. Somebody usually doesn't answer. I want to get some people's confidence up. Tim looks like he wants to talk.
What was the question again?
What parameters will extend env take? I'm writing extend env. Extend env is an ability that will extend an environment. If it helps you think about it right now, we will extend an empty environment with one additional variable value pair. What parameters do we need to make that work? Everything you need to know is right here. Why a list? Oh, this guy just takes in a single var, single val.
Oh.
But you're right, moving down the line, as we create complex environments, we're going to probably want to have the ability to have 2 or 3 different variables inside of a single environment. So what are our parameters here? To extend an environment, what does it mean to extend an environment? It means add a variable value pair to an existing environment. So if I'm going to add a variable value pair to an existing environment, what do I need to build that new animal, to build that new extended environment? Yeah, how do I construct it? What parameters will I need to construct it? If I've come and asked you, so you know what, I got this environment at home. Okay. It's creepy. Just roll with this, all right? Okay. Got this environment at home. And I got this new variable and a value that I want to extend that environment with. Is that something you can do for me? You say yes. Okay. And it's like, okay, what do you need from me in order to accomplish this? I already have it. I have the environment at home. It's just sitting there. Okay, and here's my variable and value. I want to extend that guy with these guys. You can do that for me. You already told me. You're committed. All right. So what do you need to do the job? Well, that's the job. You're my constructor. I'm hiring you to do this. What, are you going to outsource this?
Of
course.
I would build that.
Okay, well, so tell me, what do you need from me in order to build it? You're that constructor. You're the guy here called Extend D&V. I want you to take my existing environment that I have sitting here at home. It's got a little dust on it, but it might be dust. And I have a variable and a value that I want to extend that with. And you've told me that you're in the business of extending environments. So what do you need from me in order to do your job?
Tears, 1,000 goodness.
Remember earlier when I said we make this more complicated than it has to be?
Yeah.
Just the variable and the value. You just need to give me those, and then I'll just.
I'll give you the variable and the value in this environment, and you'll extend it. Those are the three things you need, right? The variable, the value, and the environment that you're extending. And you're going to give me back a new environment that has the new things in it and the old environment encapsulated within it. So forget about the implementation side of it. All I'm talking about is you've told me that you can somehow magically take this stuff back into your creepy shed, and you can somehow extend this environment with two variables. Well, with a variable and a value pair, right? So I don't even want to know how you pull this off, okay? All I want to know is what do you need for me to do the job? And what you need from me to extend an environment is you need a variable name, the value for that variable, and the environment that you're extending. Right? That's what we need to make this happen. So we're going to take in a var, a val, and an environment. Okay, now we have some decisions to make. How do we represent an extended environment? What I mean by that is back here, I kind of put together this little, kind of halvesy type of environment type thing going on here, right? So this is a variable value pair. This is a variable value pair. This is a variable value pair. And as of right now, I just have this inside of a giant list. But now, I'm telling you we're going to start with this empty env. Okay, so that's our empty environment that I've constructed. This is the thing I have in the floor of my house. All right, I'm handing that to you, and I said, you know what? Here's A and here's 5. I want you to take that empty env, and I want you to extend it with this variable value pair. Can you describe for me what your final product you'll hand back to me might look like? Okay. And there's not necessarily a right answer to this, right? Okay, so being scheme, we can probably start off with, it's going to be a list of something. All right, so we can probably start with the list. We know that somewhere in that list, we're going to have our empty environment, right? Because I'm extending that, so that empty environment needs to be in there somewhere. So there's my empty environment. So now the question is how do I represent the A in 5? Do I just put it in there like that? Or do I store it as a list that is a name value pair? List maybe makes sense? Yeah, I mean, there's not a right or wrong answer to this necessarily, right? What makes you think that this solution might be better than this solution? I want you to think about how you're going to use this solution. Because remember, well, let me ask you this. Here's a follow-up question for those you don't usually answer. Again, what are we going to use a variable environment for? Let's assume we can build it. We'll assume we get through. We have variable environments built. Why did we build it? What is its purpose? Okay. Well, that might be a feature that we'd want to have in, advanced variable environments. But just generically speaking, why do we need a variable environment?
To store different types of data.
To store variables. What are we going to do with variables after we store them? We need to look them up, right? We're going to put crap into this data structure so that later on we can get crap out of this data structure. That's the reason why we need this guy. So would it make sense for us to come up with a reasonable way of storing crap in the data structure so that it's convenient for us to get crap out? That would probably make sense, right? If you're at home, you want to have kind of convenient access to your toothbrush, right? So you don't put your toothbrush inside of a fire safe and swallow the key. That's inconvenient, right? You're only brushing your teeth sometimes, and you better brush them good because that key you're waiting on. And
Makes it more fun though.
yeah.
You gotta play find the
You're constipated. I haven't brushed my teeth in weeks.
I drink a whole bottle of laxative. It's just not working.
Why are you drinking that laxative? Bad breath. That makes way more sense than it should. Reminds me of a Doctor Who episode where he talks about some long distance call or something like that, and he points to his phone booth thing, and the lady's like, wait, that's just a police box. He says it's an incredibly accurate description or something like that when you actually think about it. But that was way out of context. But trust me, it was a good example.
How many times do you think the key can make it around?
What if it gets
Until it corrodes, is what you're saying. All right, shut up. All right, so I want to get through this. Otherwise, you're not going to have what you need for your homework. All right. Well, I'm giving it to you anyways. All right, so punchline here is we need to build our environment with the idea in mind that we can, we'd like to conveniently get stuff into it, but if we're going to build it so it works, we probably care less about that. But we really want to be able to work with our environment in a reasonable way that we can conveniently get stuff out, right? So if I need to get the value of A, I need to have it stored in such a way that I can conveniently get at the value of A, not toothbrush locked in a fire safe. Okay, we need to have it built conveniently. So let's say that I gave you this environment right here, designed like that. I said, I want you to extract the value for A from that. How would you get at the value of A? Well, you'd start off by checking to see if A exists, right? So you take the car of the environment and you'd look at it. Okay, and the car of the environment is either going to be a symbol or it's going to be a what? Or an environment. It's going to be a symbol or an environment, which you're right, it's a list, but let's start thinking about it in terms of what it represents. It is an environment. Okay, so the car in this case is a symbol. Is it the symbol we're looking for? It is. Therefore, it's the catter that we want for the value. Done. Now, what if I'm looking for a B? I take the car of the list, I see it's a symbol. Is it a B? It's not. So I know the value that's associated with this is not the value I'm looking for. So what am I going to do? I need to get to the next environment, right? So I need to burn past the car and the catter to get to everything else, right? All right, so now we're kind of manipulating these lists. Well, if I look at my second implementation here, what can I do? I can take the car of this, which gives me that to list. I could say, does the car of that list, is the car of this list a symbol? Really, I'd ask, is it the null list? If it's the null list, that means it's the empty environment, right? Okay, so is this the null list? If not, then it's got a name value pair in it. So I'll take the car. Is this the variable I'm looking for? Yes, it is. Therefore, I'm going to take the catter to get the value that I want, or the CAADR of the full list. But when I take the car of this list, I'll have that. The car of that list is the A. The catter of that list is the 5. If it's not what I'm looking for, all I have to do is take the cooter of the rest of the thing to get this list. Make sense? So it seems to be more convenient to work with if I'm representing it as lists like this. Go ahead.
Now, when you're building this stuff and you're storing it and building a programming language in general, how do you utilize like storing it in memory? Because I know we talked about that in other classes.
You mean like how does it get into memory?
Yeah.
Okay. This becomes part of the whole big chain of events that have to occur for your code to start off in text. in Java or whatever, and ultimately actually find a real place in memory. So at some point in the middle there's communication. So it goes from a high level to a low level. Then we have this thing called a linker. And the low level language is going to be like assembly. And then at runtime, the linker is going to be converting things into actual places in hardware. So now things have gone from software into electrical signals, and now they're flowing through hardware solutions to problems.
So we don't actually design how we communicate with memory?
No, we're designing an interface. So at the end of the day, any software we write, its job is to talk to hardware in the way the hardware is currently built, in terms of the tools in terms of the magic tricks it knows how to do. Okay, so our hardware, our memory manager, for those of you are in the operating systems class, we're going to be talking about this in there. So our memory manager knows how to do certain things. Specifically, it knows how to do things regarding putting things in and taking things out of memory. Pretty good at that. All right. So given that, we're going to ask that memory manager, when we get down to the operating system level, it's going to say, I have something new. I need you to store this. You got to do it in a really creepy voice. It's important. And then you're going to rely on him, the people who wrote the operating system, to do an accurate job of, once you've handed it off, it's no longer your problem. Okay, because what you're saying is, I need you to store this. It's going to run off and do whatever he does, and he's going to come back with a memory address. Like, here's your receipt. Here's where I put it. And that's what returns to us from the new keyword. Does that make sense? Okay, so it's this giant world we're playing in, and all these little pieces interface with each other. Okay, so let's build this extend env. So extend env is going to take a var, a val, and an environment. And what are we going to build? We're going to cons. We want to put these two guys in a list. So we're going to cons the list version of var val onto env. Will that construct an extended environment? So whatever var and val are, I'll turn into a list. I'm going to take that list, and I'm going to cons it onto whatever our environment currently is. So if we want to build kind of something that's out here, so we're going to go ahead and we're going to start off with the empty. Let's do, just empty, env. That will construct an empty environment. And then what we're going to do is we are going to extend that empty environment with a variable a value 5, and this needs to be quoted. Yeah, thank you. I was testing you. You failed. Okay, so I'm going to extend that environment, passing it a for var, 5 for val, and the environment that is the empty environment. And ultimately, that guy's going to boil down to an extended environment. That's a list containing the empty list. That's the nothingness there at the end. Okay, if I want to extend that environment, I can extend that environment, extend env, passing it a b and a 7, and this environment to extend. And then there's that guy. Make sense? All right. So again, the code is easy. It's considering how these constructors work and how an environment is an empty environment that then gets extended with variables on top of that. All right. All right, so an environment expression is either an empty environment or it's an extended environment that takes in a variable name, a value, and an environment expression. Did we just write constructors for this grammar? Good to go? All right. Now, good news here is you didn't write the data structure versions. You can't use this code. All right. So down here, we've already implemented a different representation of the variable environment, right? We have a different one. we need to rewrite apply ENV. And this guy says to give us a more informative error message. We don't care about that. So I'm going to kind of make up my own questions here. Then we're going to add to this environment variable an observer predicate asking whether something is the empty environment. All right, so we need a function define apply env. Let's actually write it out here. So apply env, what does this guy do? This guy takes in a variable name and returns the value of that variable in the most local scope. That's what apply env does. Empty env returns true if the given environment is empty and false otherwise. Make sense? All right, let's see if there's another function I want you to write as well. All right, and then finally, yeah, let's do it this way. So you're going to write these two functions, apply env and empty env. But before you write those, I want you to extend our environment implementation to support multiple variable value pairs within each scope. So make our implementation a little bit better so that we can have more than one variable value pair within a certain scope. Then write something called apply env, which will resolve to the most local definition of a variable, resolve to its most local value, or I guess return null if it's not found, something like that. Or maybe return false if it's not found, whatever makes you happy. And then also a predicate for testing whether an environment is empty. That predicate will be helpful for you in writing apply env. Make sense? All right. So we have 5 minutes left, right? Okay, so I'll put this up here in a second. Actually, let me put it up now before I forget. While I'm doing that, let's make some suggestions. How might you represent, how might you extend our current variable environment implementation so that it supports more than one variable value pair in a single scope? How might you change that implementation to support that? This is something you're all going to have to do, just FYI. So it might be in the best interest to do a little collaboration.
A list of lists that contain 2 lists. And when I say 2 lists, remember we were before when, that's a list with just the 2 elements, variable value pairs.
Mm-hmm.
Yeah.
So a list of 2 lists.
A list that contains lists of 2 lists.
Correct. So right now, let me add this here real quick. This is only homework 7? Jeez. So write that crap, and I'll give you this as kind of your starting point.
How come yours actually pastes nicely?
Well, I don't know.
Yeah, what do we paste?
Maybe because I'm using text edit There's something. No, actually, I don't know.
Curiosity on Blackboard. Can you put for point decimal a negative number?
I have no idea.
That would be hilarious.
The best you can do is lose 100 points.
Yes.
All right, so if we look at the current implementation here, so let's say that my environment, so we dumped this guy, right? We said that this is our winner for our current. So this is the guy we currently have implemented right here. So if I want to also put B is equal to 7 in there, he wants to replace this environment right there. Let's gotta take that out for a second. He wants to make a list of 2 lists like that. And that's actually what gets consed onto our extended environment. Is that what you're suggesting? List of 2 lists is what, so a extended environment is a list of 2 lists consed onto an existing environment. How would you take in, if you were writing extend DNV to support adding multiple variables, how would you take that in as an input? This gets back to our conversation about making sure we can get things conveniently in and conveniently out. Well, our conveniently out is going to be our apply ENV that we haven't written yet, that you guys are going to write.
Well, if each list within the outer list, so not the 2 lists, but the one outside of that, is basically the scope. So you have to specify which scope you want to.
This dude is a scope, right?
Yes.
Okay, that dude's a scope, and that scope contains 0 or more 2 lists, let's say, where each 2 list is a variable value pair. Okay?
So you'd have to specify which scope you wanted to add your new variable value pair to.
I want to extend this environment right here. You have to rewrite extend ENV to allow me to extend that guy with both A is 5 and B is 7. How do I pass all that information in here as parameters to extend ENV?
A list of variables. So instead of passing in just do what we've been doing, making a list. So it's extend DNV takes in an environment and a list, and the list contains 1 or more 2 lists.
Oh, so you want the person to pass in the 2 list, the people call it? I mean, I suppose that's reasonable enough.
It's going to have to be formatted some way. So.
What might make, if you want to kind of adapt what you currently have. Go ahead.
How does that make multiple variables of ENV?
Like multiple variables of what?
ENV, give them like a one.
Oh, okay. Well, so that's what we're trying to avoid. We want to have our 2 new variables A and B within the same scope level, not because right now we could have A and B added, but we'd add A first, and then we'd add B on top of that. No harm, no foul, right? Okay, we'll come across it at some point, but we want them to be in the same scope level. What I might suggest, just as a hint, since we're out of time here, why not take in something like that? The environment we're extending, the list of values, and the list of variable names. So from a programming perspective, we can look at this as kind of like a parallel array type of approach. So A corresponds to the 5, B corresponds to the 7, so on and so forth. Does that make sense? All right, so homework is up. I will see everybody on Tuesday. Quick announcement. If any of you are interested, it starts tonight, and I bet you they're still looking for groups. So we have 2 different groups from the computer science department competing in what's called CU Launch. I posted about it on Slack several weeks ago, which is a entrepreneurial competition here on campus. We're competing for $5,000, no strings attached. So if you have a, huh?
Do you know a lot about this, or
I got a word.
telling us about
I know quite a bit about it. I'm competing in it. I have a group in there. Another computer science group is in there. And I'm saying if any of you have a decent idea for a project that you're looking for some motivation to extend that and take it to the next step, I'd encourage you to come to the launch party tonight. It starts at 5 o'clock. It's in the pharmacy building. I'm going to be meeting the other students there at 4:50 in the thing. I'm sure they'll let you sign up late because they're looking for teams still. But if you have a project idea that you'd like to incubate to something bigger, I'd encourage you to do it, if nothing for nothing else, just a learning experience.
That sucks because I can't call off work today then because it's pre-launch.